We'll talk in this video about solvation. So first, what is solvation? Solvation is a process when you have an interaction between solvent and solute molecules. So if you have an interaction between solvent and solute molecules, so it means that we will have a solvation process. And we have a special case here for solvation. If we have a solvent like H2O, this one, if we have solvent H2O, which is water, so we can call this hydration. So how the solvation will be occur? So we have a rule here. This rule is called like dissolves like. So what do we mean by like dissolves like? It means that each group will dissolve the same group or the same category. So we have two groups here, which the first one, which is polar, and second one, which is non-polar. If we have a polar solvent, like H2O, so it will be it will dissolve a polar molecule. So what do we mean by polar solvent? So H2O is polar molecule. It means that it has two charges, negative and positive, and each molecule can have these two charges if it's a covalent one, and it has a difference in the electronegativity between the atoms inside it, and of course it can be determined by the electronegativity difference and Lewis structure. So we have a difference in the electronegativity, and according to this Lewis structure, which is bent, so the whole molecule will be a polar molecule. So this one has two charges, negative and positive. So it can attract any molecule will have the same charges, positive and negative, because we will have an attraction between the opposite charges. So if we have HCl, we know also that HCl is a covalent, and HCl has two poles or two ends, negative and positive. So we have an attraction here between hydrogen, which is positive, and a negative end, which is chlorine with hydrogen from H2O. So this if we have a covalent one. What will be the case if we have an ionic one? So for ionic molecules like Na, or ionic compound like NaCl, we have ions like positive charge and negative charge here. All the ionic molecules ionic compound will form a lattice. So we will have a lattice which is formed of positive and negative ion. This lattice, if it will be contact with H2O, so what will happen here? The positive end of H2O, which is hydrogen, will attract to the negative ion, and the oxygen, which is negative end, will be attracted to the positive, and they will grab this ion away from the lattice. So we will find that this lattice will be disappear. It means that we have the solvation here. So in nonpolar molecules like CCl4, like CH4, like C2H6, these molecules are nonpolar because first they are tetrahedral according to Lewis structure, and the difference in the electronegativity is not that strong. So like this one will be dissolved in each other. So nonpolar molecule will dissolve in a nonpolar molecule. So what is the kind of the attraction that will be happen if we need an attraction to make the solvent dissolve in a solute. So what is the attraction here? We don't have a charges. The attraction here, it will be dispersion. One of the intermolecular force, which is dispersion force. And dispersion force will form charges, will form poles, but these poles are not permanent. So it will be formed for second, or it will be formed for a small part of time. And again, it will be disappear. Now we need to talk about solvation and energy. We need to determine, is this solvation or this process will be an endothermic or exothermic. So first we need to know that we have two steps here in any solvation. The first, we need to get the solvent and the solute molecules away from each other. So we need to separate between the solvent molecules, and we need to separate between the solute molecules. And because we have an interaction between solvent itself and solute itself. So here we need energy. So because we are going to break intermolecular force, or we are going to break the attraction force between solute itself, the molecules itself. So it means we need energy. And the second one, we will form an interaction between solvent and solute. And if we form a bond, it means this one will give energy. So we have two steps. The first one will be we need energy, and the second one, it will give energy. So let's see an example for this one. So if we are talking about H2O, and maybe we are talking about HCl. So between the HCl molecules, we know that we have a negative and positive end. So it means that we have an interaction here. So we need to break out this intermolecular, to break the intermolecular force between HCl. So we need energy here to make HCl and HCl with no interaction between these two molecules. And again, if we have water, so we have H2O and we have H2O, so we have an interaction between oxygen and hydrogen from different molecules. So we need energy to remove this intermolecular force and make the H2O separated from each other. Now we have the solvent and the solute with no interaction between their molecules. Now we will make the interaction between the solvent and the solute. This will be step number 2. So the interaction between will be between this one, and maybe we will make an interaction between this one and this one. So we will have an interaction, we will form a bond here. So if you form a bond, it means that this one will give energy. So delta H here, it will be a negative because this one will be exothermic. And here delta H will be a positive one because this one will be endothermic. So we have two processes here. The first one, when we are trying to break or make the solvent and solute away from their molecules, so we will need energy because this one is endothermic. And again, if we form the interaction between solvent and solute molecules, so it means that we will form a bond, and when you form bonds, it will give you energy. So the total, which is the sum between delta H1 and delta H2, this will be determined if this one will be endothermic or exothermic. If it's a negative sign, so it will be exothermic. If it's a positive sign, it will be endothermic. Okay, thank you, and see you again, inshallah.